Today I want to talk about a really interesting question. So in this question we have two blocks A and B, and they're both, so block A is being pushed by a force of 10 Newton, and we want to calculate the acceleration, the force on block B, the normal reaction between A and B, the distance traveled in 10 seconds, and the distance traveled in the 20th second. Alright. So before we do all of this, let's draw a free body diagram. Alright, so on block A, we obviously have gravity and its normal reaction, but we can ignore that as they are both balanced. So it has a force of 10 Newton, and I am going to assume that this is accelerating in this direction. So, and the normal reaction of block B, alright, let's call this N1, is opposing the force of 10 Newton. Alright, so here I'm going to guess that 10 minus N1 is equal to MA, where M is obviously 2 kg, so this is 2A. And in block B, which is 3 kg, alright, there isn't a force of 10 Newton directly on block B, so I'm going to guess that just the normal reaction N1 is going to apply on block B. Alright, so I'm going to assume that its acceleration is in this direction, so that means that 3A is equal to N1, or I can write it backwards. N1 is equal to 3A. Alright, let's call this equation 1 and let's call this equation 2. Alright, if we add both of these, then we can see that 10 is equal to 5A. So that means A is equal to 2 meters per second square. Alright, so we have the first value. This is 2 meters per second square. Now we want to find the force on B. Right, the force on B is just N1, which is equal to 3A. So it is equal to 3 times 2, which is 6 newtons. Now the normal reaction will obviously be equal to the force acting on B. So this is also 6 newtons. Then the distance traveled in 10 seconds. Alright, assuming that the initial speed is 0. Alright, then in the fourth question, S is equal to half of A times T square. Alright, which is equal to 1 by 2 times 2, and this is 10 seconds, so 100. Alright, so it is equal to 100 meters. Now the 20th second, alright, S20. Alright, this is equal to half. So if we want to derive this formula, I'll do that at the end of this video. So the formula for this is half A 2n minus 1, or 2t minus 1, where tth second is being used. Alright, so this is equal to half times 2 times 2 times 20 minus 1. Alright, so this is equal to, these two get cancelled, so 40 minus 1, which is 39 meters. Alright, so this is 100 meters and this is 39 meters. Alright, I do have another question other than this one, but before that let's derive this formula. Alright, in the nth second it will travel Sn minus the remaining time that it took. So that means Sn minus 1. Alright. So Sn is equal to 1 by 2 times A times n square. And this is equal to half times A times n minus 1 whole square. Alright. Which is equal to half A n square minus n minus 1 whole square. Alright, which is equal to half A in bracket n square minus n square minus 1 plus 2n. Right, we opened this bracket like this. So that means this is equal to n square minus n square minus 1 plus 2n. Alright, which is equal to half A. N square and n square get cancelled. So this is equal to 2n minus 1. So that's how you get this formula. Alright, now we have a really interesting problem. Alright, this is question 1 and this is question 2. Alright, in this there are 3 blocks. Alright, M1, M2 and M3. Alright, and a force is pushing them, force F. Alright, then what is the acceleration of M3? Alright, so now let's draw the free body diagram for each of these. Alright, this is F. I'm going to assume that acceleration is in this direction and the normal reaction N1 is opposing M1. Alright, so that means F minus N1 is equal to M1A. And now for the M2 block, alright, N1 in this direction and N2 from the third block, M3, is in this direction, and I'm going to assume that its acceleration is still in this direction. So that means N1 minus N2 is equal to M2A. Alright, and M3, for the M3 block there is just N2, and acceleration I'm going to assume that it is in the same direction. So that means M3A is equal to N2. Alright. Now, can we see something in this? From these 3 equations, I'm sorry. Alright, from these 3 equations right here, do you think that we can substitute the values? Well, of course we can. N2 is just M2 N1 minus M2A, right? Over here, N2, if we bring this to this side and we take this side, then N2 is equal to N1 minus M2A. Alright, so let's just substitute that. M3A is equal to N1 minus M2A. Alright, and what do you think is N1? M3A is equal to N1, if we bring this side and we take this side, N1 is equal to F minus M1A. Alright, so this is equal to F minus M1A minus M2A. Alright, so now we bring the M1A and M2A to this side. Alright, so that means F is equal to M1A plus M2A plus M3A. Alright, so F is equal to A in bracket M1 plus M2 plus M3. Alright, so that means acceleration of all of the blocks, alright, all of the blocks is equal to force upon M1 plus M2 plus M3. and this is the answer. Thanks for watching. Bye.